All right, we are going to look at finding the quotient of polynomials, and we are going to do this by using a synthetic division technique. When using synthetic division, we need to be looking for dividing by something of this form. This is the independent variable minus a constant. If we have that form, then we can go ahead and proceed with synthetic division. Looking over here, we have x minus 6. 6 is a constant. X is our independent variable, as we also see up here. So we meet this form, so we have met the check. We can do synthetic division on this as opposed to the polynomial long division. The setup for synthetic division is really important. Anytime that we are missing a power in the numerator, we need to replace that power with a 0 because in the synthetic bracket we want the coefficients for each power, and if one's missing, that means the coefficient must have been 0 because 0 times x to whatever the power was results in a product of 0. So 0 is technically needed here. So we create our L bracket here, and then we want to write inside here just the coefficients of the x's without the variables. So we have x to the 4th power, that's our starting position, that's going to be 3 is the coefficient. We don't have x to the 3rd power, so that's going to be a 0. We have the 2nd power, that's negative 5. We have 1st power, that is 4. And we have a 0 power, that is 3. On the outside here, we are writing just the c value here. So this is 6, that's positive. Remember, the form showed x minus c. So c is whatever is being subtracted from x, which is 6. So this is our setup. Inside the synthetic bracket, we are always adding. Outside, coming around the corner, we're always multiplying. So we have 3 plus nothing is 3. 6 times 3 is 18. 0 plus 18 is 18. 6 times 18 is 108. 108 minus 5 is 103. 6 times 103. All right, so 618 plus 4 is 622. And so we need 6 times 622, which is 3,732. And then 3 plus 3,732 is 3,735. Now this final line here, this is known as the depressed polynomial. This is going to be the quotient of this polynomial divided by this polynomial. This doesn't look like a polynomial yet. We have to add the independent variable back in here with all the powers. But when we do that, we do one less power than we started with in the numerator. So we started with a 4th power. We're going to insert a 3rd power here. So this is going to be the coefficient for x to the 3rd power. And then this will be the coefficient for x to the 2nd power, and so on. This is descending order. And then when you run out of your x's, this doesn't have an x. This is your constant for your polynomial, which is because this would be x to the 0 power, which would be 1. And so you have 1 times whatever your coefficient is, leaving just your coefficient as the constant. We have one extra number here that wouldn't get an x at all because it's beyond x to the 0 power. And this is going to be our remainder, and you do the same thing that you would do with the remainders if this were like a 4th or 5th grade class. It becomes the numerator of the thing that you divided by, and the thing that we divided by is x minus 6. So the remainder portion here is the numerator for a fraction. So this polynomial right here is the quotient of dividing this polynomial by this polynomial. You get this polynomial. Polynomials are a closed system. And so when you take two polynomials and you do an operation, you get a polynomial as its result. So this is going to be the quotient. So we've divided these two and gotten this as our quotient. That's our solution. For hopefully this has been interesting and educational for you. Cheerful calculations.